So, is it audible? Is it audible? Okay. So, do you have any questions from the previous class? Any questions? Any questions? Okay, fine. So, let us start. So, we will solve some of the problems based on the previous understanding, right? No video. Can you see now? Maybe you can refresh, Jakir. You can refresh. So, problems on equilibrium of rigid body. So, note down one problem. Three forces PQR act along the sides of a triangle formed by the lines x plus y is equal to 1, comma, y minus x is equal to 1, comma, and y is equal to 2. Find the equation of the line of action of the resultant. The line of action of the resultant. Can you try to solve this? There are three different forces and all the three are acting on the sides of a triangle which was formed by the lines x plus y is equal to 1, y minus x is equal to 1 and y is equal to 2. So, these are the three different lines on which the line of action of each and every individual force is there. Now, the combined effect of all the forces together, we need to be finding out the resultant line of action. Right? Can you try to solve this? First, you draw the straight lines, and these straight lines are, so one is, so I will take a standard coordinate axis. This is x axis and this is y axis. And these straight lines x plus y is equal to 1. When x is equal to 0, y is equal to 1. That means when x is equal to 0 and y is equal to 1. And this is one place. And when y is equal to 0 for this, so x is equal to 1. That means this is another point on this particular straight line. So, you can draw a straight line like this. So, this is one straight line which is represented by x plus y is equal to 1. Similarly, if you draw the line of this one, so when x is equal to 0, y is again 1. So, that means the other line also it will pass through the same point, and when y is equal to 0, x is equal to minus 1. That means it will be exactly opposite and it will be somewhere here. So, that is, if I try to draw the line like this, so this can be extended like this. And one more straight line, that is y is equal to 2. So, this is y is equal to 1. and then here actually maybe you can think of y is equal to 2. So this is y is equal to 2 line. Now he is talking about three different straight lines. This is one, and this is the second one, and this is the third one. So there are three different forces that are acting on this. So those three different forces are P, Q, R. So on the first line, so x plus y is equal to 1. So there is a force of P is acting on this line. And there is a force of Q acting on the second line, y minus x is equal to 1. So along this line, so this is Q. And along the third line, so y is equal to 2. So the other force is acting. So this is y is equal to 2 line, and where the R is acting along the line. Got it? How can we choose the direction? So in the problem statement, three forces P, Q, R act along the sides of a triangle formed by the lines. Now actually three different lines actually he has given. Now actually unless otherwise it is specified, right? So you can take it sequentially forming this. Got it? Understood? So for this one and this one actually no confusion, but for this actually you might get confusion, but actually unless otherwise specified, you take it sequentially so that you won't get any confusion on this. Got it? Okay. So for my understanding, right, so this is actually a negative slope and this is a positive slope. So positive slope will go high and negative slope will come down. So that's why actually this is the direction I have taken for this, and this is the direction I have taken this, and then actually I have continued to close this. Got it? So this is in a serial manner. So here actually find the equation of the line of action of the force based on this understanding, and this is actually 1 comma 0 point, and this is minus 1 comma 0 point, and this is 0 comma 1 point, right? So now actually we have got all the information that is needed here. So based on this information, can you try to find out the equation of the line of action? So we have actually the line of action which we have derived in the previous class, that is x into capital Y minus y into capital X is equal to m is the line of action of all the forces. So this was derived in the previous class, right? Based on this understanding, so we have to summarize that we need capital Y, we need capital X, and we need M. So if you are able to find out these three values, you will be able to substitute here, where capital X is the algebraic sum of all the force components along x-axis, and y is the algebraic sum of all the force components along y-axis, and then m is the resulting moment of all the forces. So based on this understanding, if you are able to find out x, y, and m, so you can substitute back to get the line of action of the force. Got it? So now actually you can solve it. So that actually you have to take. About which point we have to consider the moments of the force. So based on certain understanding, actually we have derived this equation. So what is that understanding? When we derive this equation, we have considered the moments of all the forces about the origin. So here actually whatever the origin we select, right, about which actually we have considered and derived this equation. Hence here also you have to consider the moments about this particular point. Got it, Vishal? Anybody got the answer? Okay, so let me solve this. Okay, so here actually we can find out the force component along x-axis is equal to, so this force is acting downwards, that means this is the positive x direction. So positive x direction, and if you notice this height is 1 and this length is also 1, then actually height and length are equal, so this angle is 45 degrees and this is also 45 degrees, and then so this will make 45 degrees and this will also make 45 degrees. Got it? Yeah, so this is 45 and this is 45. Now actually based on this understanding, so this is also, this is 45 degrees, this is 45 degrees, this is 45 and this is 40. Yeah. So all are 45 degrees only in this particular case. Now the force component along x-axis. Now actually if you project along x-axis, this is minus P into cos 45. And then this force component is also, sorry, this is plus. Why? Because this is towards the positive x direction. This P force component along the positive x. And even Q also positive x direction only. So that is Q cos 45. And then this R is acting in the opposite direction. So that is minus R. So this is P by root 2 plus Q by root 2 minus R. So this is the force component along x-axis. Yeah. So and the y component of the force is this y component. So vertically. So this is completely horizontal. So R you can remove it. And this P is acting downwards and Q is acting upwards. So downwards is negative and upwards is positive, and both are making an angle of 45 degrees with the vertical. So minus P cos 45 plus Q cos 45. That means this is Q minus P by root 2. So this is P plus Q minus root 2R divided by root 2. So this is x and this is y. We have got two different values. And the other one what we need to be finding out is the m. So m about the origin. So m actually you can find out the force getting multiplied by the perpendicular distance. So perpendicular distance is, so this is actually the P force, and about this point there is a perpendicular distance of this one. This is the perpendicular distance. Now, the moment of the force P about O is nothing but this length. So we know that this is actually, so this is the value of 1. So this angle will be 45 degrees. Because actually this is 45 and this is 90 and this is 45 again. So if this is 45, 1 into cos 45. So this length is 1 into cos 45 is equal to 1 by root 2. 1 by root 2 is this length. So you can calculate the moment is equal to m1 plus m2 plus m3 or mp plus mq plus mr. So mp equal to, so p into cos 45 is 1 by root 2. Now here actually when you calculate, right, so moment, right, you have to consider the direction. So direction is, so when you are considering the direction, listen carefully, so it will give a lot of confusion. So see this, so I follow a standard convention. So from the point about which we are calculating the moment, from there actually draw the perpendicular line like this. And then actually treat that as R. And then this is the force direction. So draw an arrow there. So R also you have draw an arrow, and the force direction also you draw an arrow. From outside R to P you follow. Outside R to P. So this is the direction actually you can put it. So this arrow, if it is clockwise, you treat as negative. If it is anti-clockwise, you treat as positive. Now actually when you are moving from R to P outside, this is clock. So negative. So here actually you put negative. So minus P into cos 45. And again here this is Q force. And from the origin this is the perpendicular distance. So again it makes 45 degrees here. And this length is 1. So this length is also again cos 45. So this is Q into cos 45. Now when you are keeping the sign, so you extend this radius like this, and this is the force direction, and then draw an arrow like this. Got it? So from R to P you need to draw. So here actually, sorry, this is actually Q is going upward. So as Q is going upward, R to P, this will be again clockwise. Again it is negative. So this is the force direction and this is the radius direction. R to P, R to the force in the outward direction. So this is again negative. So this is a clockwise. So you keep negative. And for this force, this is the third force R about this particular point. So this length is 2 and this length is 2. So this is the radius direction and this is the force direction. R to 4. So from radius to the force direction, if you draw a curve like this, so this will be anti-clockwise. So hence it is positive. So the perpendicular distance is 2 units and the force magnitude is R and the orientation is plus 2 times of R. So this is the moment. Got it? So this is M. So this is minus P by root 2 minus Q by root 2 plus 2R. So this is M. So substitute in the original equation of small x into capital Y minus small y into capital X is equal to M. So this is the equation of the line of action. I hope everybody got the clarity on this. Any questions on this? You can let me know. Any questions? So here actually only confusion is actually putting the sign on the moments. That is the confusion. So you want me to recalculate y component. So y component actually, so this is actually p direction in the negative y direction. So downward. So this angle is 45 degrees. P into cos of 45. Right? So sorry, this angle is also 45 degrees, right? I have taken P into cos 45. So because this is also 45 and this is also 45, it is not making any difference. Cos or sine, right? So this is 45 degrees, P into cos 45 in the negative direction. So that is minus p cos 45. And q is actually upward direction and it is making with y axis 45 degrees. Again q cos 45 in the upward direction. So this is q cos 45. Got it? R actually it's not in the y direction. So it talks about only the x direction. Hence you can ignore the R value for y. Yeah. Okay. So note down one more. Yeah, y is equal to 2 line makes anti-clockwise rotation here. Two equal unlike parallel forces, two equal unlike parallel forces acting at fixed points A and B form a couple of moment G. A and B form a couple of moment G. If their lines of action are turned through, if their lines of action turn through one right angle, they form a couple. One right angle, they form a couple of moment H. Show that when they both act at right angles, show that when they both act at right angle, to AB, they form a couple of moment. They form a couple of moment G square plus H square under root. Can you try to solve this? Unlike means anti-parallel. Anybody got the answer for this? Okay, so let me solve this. See this. Two equal unlike parallel forces acting at fixed points A and B form a couple of moment G. If they result lines of action turn through an angle of right angle, they form a couple of moment H. Show that when they both act at right angles to AB, they form a couple of moment B square plus H square under root. So suppose let us say this is point A and this is point B. Right now, so there are two different forces. So their lines of actions are like this, and these two are actually parallel to each other but opposite direction. Let us say this is making an angle of theta. So if this is making an angle of theta and this point is A and this point is B. So for a couple actually we have calculated the moment. So the moment of a couple is always the perpendicular distance between these two forces getting multiplied by the force. So if this force is P and this force is also P but in the opposite direction, if this angle is theta and this is also theta, because these two are anti-parallel to each other. Right? Now the perpendicular distance between these two is nothing but this length. So this length is nothing but, so this is AB sine theta, is this particular perpendicular distance. So I call this as D, AD. AD is the perpendicular distance. So the moment of the couple when they both are parallel to each or anti-parallel and acting at an angle of with AB is G. That means here actually in this particular case, so the couple moment M is, so this is G. So G is nothing but AB sine theta getting multiplied by P. So this is the couple moment G. Now actually what he said was, now these forces are turned through an angle of 90 degrees. That means this also turned an angle of 90 degrees and this also turned an angle of 90 degrees. So in that case actually what happens is, now actually let us say this is making an angle of 90. So from here actually it rotated an angle of 90 degrees. So if it rotates by an angle of 90 degrees to AB, see this, so this earlier it was like this. Now actually, so it rotated an angle of 90 degrees like this. So this P, so now actually this became this one. And this also rotates an angle of 90 degrees. That means this will go like this. Got it? So earlier actually it used to be like this, and this is theta, and then from there actually it rotated an angle of 90 degrees. That means now the new couple angle of 90 degrees, then H is equal to, so P into AB sine 90 plus theta. Got it? Sine 90 plus theta. And then this will be H is equal to AB into P into sine 90 plus theta is cos theta. Cos theta. So this is G and this is H. Got it? So this diagram actually rotated in the other direction, we take it. If this is theta, and from here actually take 90 degrees like this. So this also, this is theta, and this rotates by an angle of 90 degrees. Like this it will come. Okay, I will just draw here. Earlier it was like this, and this is 90 and this is theta. This was theta and this is 90. Yeah. Got it? So this is how actually it was rotated. It rotated by an angle of 90 degrees. Then actually the new couple is AB cos theta. So earlier actually this is AB sin theta into P. Now it is AB cos theta into P. Now when they both are at right angles to AB, then the new moment will be. So first you note down this, we are going to calculate that. Done? Note it down. Okay. Now actually the new couple, when both are acting at an angle of 90 degrees to AB, so that will be directly the multiplication of AB with P, because both are acting 90 degrees to AB. So this is the third case, or else actually you draw this to the top and this to the bottom. Anything should be fine. So when it is 90 degrees, then the perpendicular distance is straight away this AB, right? This is the perpendicular distance between these two parallel lines. So the new moment will be, let us say, M is equal to AB into P. So this is the force P and this is P. So AB into P is the new moment. Now this AB into P, we have actually G is equal to AB into P into sin theta, and H is equal to AB into P into cos theta. Now G square plus H square is equal to AB in square into P square into sin square theta plus cos square theta. So this value is anyway 1. So G square plus H square is equal under root is equal to AB into P. So AB into P can be replaced with M is equal to G square plus H square under root. I hope you understood. Got it? Any questions on this? Okay. So note down one more. If a system of forces in one plane reduces to a couple whose moment is G, a couple whose moment is G, and when each force is turned round, and when each force turned round its point of application its point of application through a right angle, it reduces to a couple of moment h. Prove that when each force is turned through an angle alpha, prove that when each force is turned through an angle alpha, the system is equal into a couple. System is equivalent to a couple whose moment is g cos alpha plus h sin alpha. And the second problem statement also given in this, for what values of alpha will the moment of the new couple equal to the moment of the old couple. So the main difference between the previous problem and this problem is, in the previous problem he is talking about only two forces which are forming a couple, and that too equal and unlike forces. That means a couple it was given. Now here actually the couple moment was g. In the previous case actually couple moment was given, and the two forces actually turn through an angle, and actually again it forms a different couple. Now he asked about the relation between those two. Now here the case is the complexity is increased to n different forces. Now actually some of the basic theorems whatever we have learned in the previous sessions actually that needs to be used. So that is, if there are n different forces that are acting on a body at different points, now all the forces together can be replaced with a single force which is acting at a randomly chosen location along with a couple whose moment is equal to the resultant of all the forces together. And that couple actually, so one force is anyway the force that is acting at the origin which is randomly chosen, right? Now here actually such kind of case it was given. So it's not just only two forces. If there are n forces, then that n forces has to result into a single force acting at a randomly chosen location along with a couple. And indirectly he has given one more statement, that is, so all the forces together results into a single moment called g. That means no effective force, only moment is there. So r equal to 0, indirectly it was mentioned here, right? But g is not 0 or m is not 0. So that m value is, in the first case it was g, and after that actually it turned through an angle of 90 degrees. Again actually it forms one more couple, and that couple also moment h. And suppose if it randomly rotates an angle of alpha, then what would be the resulting moment? So that resulting moment value in terms of the known moment values actually we have to be expressing it. So that is a problem statement. So the body when it is like this, and if there are different forces that are acting on this, now all the forces together are actually resulting in a moment of G. Now actually every force is rotated through an angle of 90 degrees. So this force also rotates like this force rotates like this, and this force rotates like this, and this rotates like this. Now all the forces are rotated. Now again actually there will be a moment depending upon the rotation, right? That moment actually it was G. Now actually what if it is an angle of alpha rather than 90? So that is the problem statement. So try to understand this and then solve it. Anybody got the idea how to solve this? Yeah, you need to consider, right? Obviously, you have to consider the only way is when there are multiple forces that were given, right? So the standard way of approach is always resolving all the forces into two different directions, one along x-axis, another along y-axis, so that you can simplify 100 different forces or 200 different forces. You can bring into only two different forces. One is along x-axis, another is along y-axis. Now actually the problem statement will be very simple. Anybody got it? Now let me solve it. Here actually, so when there are n different forces, so the resolved components or the algebraic sum of all the forces resolved along x-axis capital X equal to sigma r equal to 1 to n. So Fr cos theta r, where cos theta r, this theta r is the angle. Now actually if you randomly choose the, so this is actually the x-axis and this is y-axis and this is the origin. So this is a randomly chosen point, right? So there is no restriction on this point to select. You can select anywhere. Now from there actually you have to draw the position vectors AR. So this is one position vector, this is another position vector, this is another position vector, and this is another, and this is another position vector. Now each position vector to the point of application of the force, it is making an angle of theta. So I call as theta r, where r can be any value depending upon the number of forces. So the same thing, Fr cos theta r. Now F1 cos theta 1 plus F2 cos theta 2 plus dash 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 up to Fn cos theta n is nothing but the cos theta factor will be the horizontal component of the force. So this is Fr cos theta r, and the sigma will relate all the forces together as a sum. So this is x. And similarly, the resolved component along y-axis, so that will be sigma r equal to 1 to n, so Fr sin theta r. So this is the resolved components, and this is the resolved component along y-axis, this is along x-axis. Now the moment of the force m, so here in this case actually g is the initial moment. So this initial moment can be calculated as sigma r is equal to 1 to n and the force components, right? So here actually you need to be calculating, so each and every force component. So this is AR. Suppose if you choose this as one particular position vector, AR cross FR, so that is AR cross FR. So this is the resulting moment, right? Got it or not? I hope you understood. So this one actually AR cross FR, actually the simplified format is sigma r is equal to 1 to n, so x into xr into capital YR minus YR into capital XR. So this is nothing but the force component of the earth force along y-axis. This is the force component of the earth force along x-axis. This is the position vector coordinates of the XR and YR, right? So let us say if you take this particular force, so this force, let us say this is F4, and this coordinates will be x4 comma y4. So this is the coordinate. So this vector is the position vector, and the force that is acting on this particular point is nothing but Fr. So or F4. So this F4 is making an angle of theta 4. So obviously this can be written as F4 is equal to, so F4 cos theta 4 I plus F4 sin theta 4 J. So this is the force component. Now if you do the cross product of AR is equal to XR into I plus YR into J, and FR is this one. So the cross product of this is going to be this one. Got it or not? I hope everybody understood this. Understood? Okay. So now actually YR you can replace with this one, and XR you can replace with this one, and small xr and small yr will be there as it is. So if you replace it, this is sigma r is equal to 1 to n xr into fr sin theta r minus yr into fr cos theta r. So for this sigma, it will be the resulting moment g. So we have got the values of x value, y value and g value. Now here actually, so all the forces together are resulting into a single moment g. That's what he stated, which essentially means that no resulting force is acting on that. So if there is no resulting force, then r will be equal to 0, right? R is equal to xi plus yj is equal to 0. It implies that x equal to 0 and y equal to 0, which implies that this value is 0 and this value is 0. Got it? So this is a fundamental understanding. So we have got only g value, which is a non-zero value, but x is 0 and y is 0, but this is not 0. So because actually it is calculated with the individual forces. Now all the forces together along x-axis is 0, all the forces together along y-axis is again 0. But individual cross products, if you add it together, it results into a value of g. Now actually, this was rotated by an angle of 90 degrees. In the second case, each theta is rotated by an angle of 90 degrees. So, in case of h, right? So, h will be this value 90 plus theta r, 90 plus theta r. Got it? First you note down this, we are going to calculate the h value. Done? Note it down. Okay. So we have got the g value as sigma r is equal to 1 to n xr fr cos theta fr sin theta r minus yr into fr cos theta r. Now h value we can calculate it. So h is nothing but after a rotation of -90 degrees, then this is going to be sigma r is equal to 1 to n, so xr into fr sin 90 plus theta r minus yr into fr into cos 90 plus theta r. So here if you notice, xr and yr will not make any change because the point of application of the force actually no change, but the orientation of the force is changed. That means exactly at the same point but rotated by an angle of 90 degrees and then acting on it. Hence the location of the point of application actually is not making any difference. So only changes only the orientation. Hence actually this fr sin theta r and cos theta r changed to 90 plus theta r. So this is going to be sigma r is equal to 1 to n xr fr sin 90 plus theta is cos theta r minus so yr into fr into cos 90 plus theta is minus sin theta r. So this is h value. So we have got the g value and we have got the h value. Now here actually, so the force is actually if you resolve along x-axis and along y-axis, now again it won't make any difference because x is equal to, so earlier actually, so x initial or actually old I calculate. So this was coming out to be sigma r is equal to 1 to n fr cos theta r. This is the horizontal component of the force initially without rotation. Now actually after rotation of 90 degrees, so x nu is going to be sigma r is equal to 1 to n fr cos 90 plus theta r. So cos 90 plus theta r is sin minus sin. So minus r is equal to 1 to n fr sin theta r. So minus of. Similarly, y nu is equal to sigma r is equal to 1 to n. So sin fr sin 90 plus theta is cos theta r. Now here actually earlier in the previous case x volt is equal to 0, y volt is equal to 0 because it results into a single component. So only moment, because all the forces results into a single moment but no effective force. So because of this reason, so this x volt is equal to, x volt is nothing but fr cos theta r. Now y nu is x volt, which is equal to 0. And similarly, x nu is y volt minus half. This is again equal to 0. Got it? So that means even after the rotation also, the resulting components of the force along x-axis and along y-axis both are again coming out to be 0. Now it again results into a moment of h which is equal to this value. So this is also proved. Now the next case is, rather than 90 degrees, what if it moves an angle of alpha? So initially it was, so fr into sin theta r and cos theta r initially. Now rather than theta r, so we have to be keeping theta r plus alpha, so that if it moves an angle of alpha from the original, then actually what would be the resulting h? Got it? So you calculate that one. First you note down this. Done? Noted? Noted down? Okay. Now actually what if it moves an angle of alpha rather than 90? So if it moves an angle of alpha, then so the resulting moment, I call this as m, is equal to sigma r is equal to 1 to n, so xr into fr sin theta r plus alpha minus yr into fr into cos theta r plus alpha. So this is the resulting moment. Now actually from this sigma r is equal to 1 to n, fr if you take out, and then this is xr getting multiplied by, so this is going to be sin a cos b, sin theta r cos alpha plus cos theta r sin alpha minus yr into cos theta r cos alpha minus sin theta r sin alpha. Now if you further simplify this, sigma r is equal to 1 to n, fr if you take out, and then here actually, here cos alpha is there, here cos alpha there, so cos alpha if you take out, what is left over here, it is xr sin theta r minus yr cos theta r plus sin alpha into cos theta r xr cos theta r minus of minus will be plus yr sin theta r. So this is what is left over. Now actually this cos alpha is anyway constant, you can take it out. Cos alpha into sigma r is equal to 1 to n fr xr sin theta r minus fr yr cos theta r plus sin alpha into sigma r is equal to 1 to n. So this one you can put it down. So first you note down this, we are going to arrange and rewrite it. Done. Noted? Okay. So now actually if you carefully notice, right? So here actually whatever is coming over here is nothing but G, and whatever is coming over here is nothing but H. So this is H and this is G. So both were actually present at this location. So along with a factor of cos alpha here and along with a factor of sin alpha here. Now this resulting moment M can be treated as cos alpha into G plus sin alpha into H. Got it? So this is M is equal to G cos alpha plus H sin alpha. So this is the resulting moment. Got it? So that's what actually he asked us to prove. So this is case 1. In case 2, for what value of alpha, so this resulting moment is equal to the old moment G. So the case 2 is for what value of alpha M equal to G. So that is the next question. So if you keep this as G is equal to G cos alpha plus H sin alpha, and the known values are G and H which were given in the problem statement. So G into 1 minus cos alpha is equal to H into sin alpha, or G into 1 minus cos alpha can be treated as, so 2 sin square alpha by 2, and this can be treated as H into 2 sin alpha by 2 cos alpha by 2. So this sin square, these 2 will cancel out, and G by H is equal to cot alpha by 2, or tan alpha by 2 equal to H by G. So alpha is equal to tan inverse of H by G. So for this value of alpha, the new moment is going to be the old moment. Got it? So initially all the forces together are resulting into a single moment called G. Then when it rotated, then the resulting moment was H, and when it rotated by an angle of alpha which is equal to tan inverse of H by G, then again the moment that is going to be come out is again equal to the old moment G for this value of alpha. Got it? Any questions? Any questions on this? So this was given in Forest Service exam earlier. I hope everybody understood. Okay. So these are the kind of problems that you can expect. So as per UPSC standard, right? So that is one trivial solution. Alpha equal to 0 is always a solution, right? Obviously, right? So if there is no movement change, if there is no angle change for any particular force, if there is no change, then there won't be any change in the movement also, right? So that is a trivial solution which you don't need to mention. Yeah. Got it? Okay. So that's all for today. So with this actually, so this equilibrium of forces is complete, right? So we'll go to the next class with a new topic. Yeah. Got it? Yeah. So I'm going to give an assignment based on this understanding. So you can try to solve this. Yeah. Thank you. Yeah. Good night.